Hello everyone, in this video we will be beginning with the chapter number 36, the scientific method and technical analysis. So this is quite a lengthy chapter, but it's going to be pretty easy and there's more of reading to do in this chapter. So we'll be talking about examining and the possibilities and challenges of applying scientific method to traditional technical analysis. We are going to analyze the three forms of the EMH and as to their information content. We will analyze null hypothesis, state the five stages of hypothetical deductive method. We are going to see the method and we are also going to see the three consequences. Technical analysis central problem is erroneous knowledge. As it is traditionally practiced, much of TA is a body of dogma and myth founded on faith and anecdote. This is a consequence of the informal intuitive methods used by practitioners to discover patterns with predictive power. As a discipline, TA suffers because it is practiced without discipline. Adopting a rigorous scientific approach would solve this problem. The scientific method is not a cookbook that automates knowledge discovery. It is a set of methods designed to describe and interpret observed or inferred phenomena, past or present, aimed in building a knowledge of rejection or confirmation. So basically science is something which has been there from ages, right? And scientific, having something scientific in which is involved in your technical analysis strategy would just increase your win rate, because it's going to have some rigorous rules, right, and a lot of backing of knowledge, which would basically enhance your trading system. Okay, this chapter summarizes its logical and um, philosophical foundations and discusses the implication of its adoption by TA practitioners. The most important knowledge of all, a method to get more. Of all the kinds of knowledge that the West has given to the world, the most valuable is a scientific method, a set of procedures. So, the first thing that should come to your mind when you're talking about a scientific method is that there is a set of rules and regulations, and there is a set of knowledge. There's a set of procedures, right? It was invented by a series of European thinkers from about 1550 to 1700. Compared to informal approaches, it is unsurpassed in its ability to separate from falsehood. The dramatic increase in our understanding of control over the natural world is basically because of the power of the science, right? If we didn't have science, then we would not even know how to use the natural resources which are available to us. The method's rigor basically protects us from the fragilities of mind, which often impair what we learn from experience using less formal methods. Although informal knowledge acquisition works well for many obvious truths, sometimes what seems obvious is not true. It was obvious to the ancients that the sun revolved around the earth, right? Because it was very obvious that we can just believe that the sun is the one which is revolving around us rather than us revolving around the sun. That's what you'll assume, right, if you didn't have any knowledge. But it's only because of science that now we know that it's not the sun which revolves around the earth, but it's the earth which revolves around it. So financial markets basically are also complex and they're also highly random, right? So we need some sort of scientific methods which would increase our ease, and it will also increase our win rate. Technical analysis has not been practiced in a scientific manner, but it is now changing. In academia and the business world, a new breed of practitioners known as quants have been adopting a scientific approach. You might have heard about quant technical analysts or quant finance roles, right? So, all of that is basically, especially in the hedge funds, everything is done by the science people. Unsurprisingly, many traditional TA practitioners have resisted this change. Vested interests and habitual ways of thinking are hard to abandon. No doubt there were opposition when folk medicine evolved into modern medicine. So every single thing which is there in the world, everything has evolved because of science. Now let's talk about the legacy of Greek science, a mixed blessing. The Greeks were the first to make effort at being scientific. Through their legacy proved to be a mixed blessing. On the positive side of the ledger was the invention of logic by Aristotle. The formal On the negative side were faulty theories of matter and motion. So there were obviously many positive things, but there were also many negative things which were given by science. Okay. The birth of scientific revolution. Science was the major discovery or invention of the 17th century. Men of that time learned, and it was very revolutionary discovery, how to measure, explain, and manipulate natural phenomena in a way that we can call it scientific. Since the 17th century, science has progressed a great deal, and it has also discovered many sorts of truths, right? So Obviously, a lot of things which were not known before the scientific century were now known, and the human history has obviously changed a lot because of the science. The revolution began in Western Europe around 1500 in an atmosphere of intellectual stagnation. At that time, all knowledge was based on authoritarian procurements rather than observed facts. The doctrines of the Roman Church and the dogma of Greek science were taken as literal truths. On earth, objects were assumed to be governed by physics. Everyone was happy until people saw that people accepted, some of the truths which were not even true. People just blindly used to accept it because there was no other alternative, or there was no scientific reason which is proving for the um, things that they were not false, right? People would just blindly believe it. Okay, so this is also the same story. You can read the Aristotle story if you're interested. Faith in objective reality and objective observations. Science makes a fundamental assumption about the nature of reality. There is an objective reality that exists outside and independent to those who observe it. And this reality is the source of the observer's sensory impressions. This faith is the basis of science's emphasis on observation. It is properly characterized as faith because there is no experiment or logic that can prove the existence of an objective reality. So, what I am basically observing, there is a reality which is not what I am observing. Okay, one might ask, why should we make a big deal out of the fact that seems so obvious to common sense? Everyone can see there is a world out there. However, in the eyes of science, this issue is a mountain and not a molehill. And it points to an important difference between knowing scientifically and knowing intuitively. Science does not accept something as true simply because it seems to be so. The history of science has shown repeatedly that the obvious is not necessarily true. Science assumes the truth of an independent objective reality, not because it is self evident, but because it is consistent with principle that shapes much of the scientific enterprise. Okay, so that is basically the principle of simplicity. Okay, so what is the principle of simplicity? The principle of simplicity basically says that simpler is better. Thus, when judging which of the several theories is more likely to be true, when all the theories are equally good at fitting a set of observed facts, the principle of simplicity urges us to accept whatever theory is the simplest. We need to go ahead with it and we need to accept it. This is the theory that invokes the fewest and the least complicated assumptions. The principle of simplicity, also known as Occam's razor. So, what is Occam's razor? Occam's razor is also the principle of simplicity. It tells us to cut away theory's excess complexity. So, whenever a theory is very complex, then you just need to not take it and you need to not engage with some theory which is extremely complex in nature. Okay, moving on. Fibonacci sequences, Elliott wave, and etc. Elliott wave principle is able to make more accurate predictions than random walk theory. Assuming the existence of an external reality simplifies matters greatly. As a consequence of its fate is an objective reality, science hold that objective and subjective perceptions are extremely different. Okay. So I hope you're understanding what is the principle of simplicity, and I hope you also understood why, what is the other name for the principle of simplicity. It is the Occam's razor. Moving on to scientific knowledge is objective. Okay. So when you're confused between whether scientific knowledge is objective or subjective, what do you think? It is objective because science strives for maximum objectivity by confining itself to facts about the world out there. It is the facts remain facts, right? Facts are the same for everybody. The facts do not change. People cannot interpret it differently or according to their own bias or their own point of view, because that is something which is extremely different, right? So that is what is known as objectivity, which means it's going to be only based on pure facts, so it would be same for everybody. Scientific knowledge is empirical or observation based. In this way, it differs mathematical and logical propositions that are derived from and consistent with a set of axioms but need not refer to the external world. For example, the Pythagorean theorem. So, what's the Pythagorean theorem? You know that, the triangle theorem. It basically, hypotenuse square is equal to the base square plus height square, right? However, this truth was not derived by studying thousands of examples of right triangles and generalizing from many. Rather, it is derived from a set of accepted mathematical postulates. So, postulates are basically facts. They are like inventions and they are like facts which are true in all cases. Okay. Scientific knowledge is quantitative. The notion that the world is best understood when described in quantitative terms is also given by Pythagoras himself. It was his contention that both the world and the mind are essentially mathematical. The importance science places on quantification cannot be overemphasized. Wherever mankind has been able to measure things, which means transform or reduce them to numbers, it has indeed made great progress. Okay, so they quantification is the best thing, and even in trading, the more you are able to quantify the strategy or quantify the data, then the better kind of results you will get. The purpose of science, explanation, and prediction. The goal of science is the discovery of rules and to predict new observations and theories that explain previous observations. Predictive rules, often referred to as scientific laws, are statements about recurring process, such as event A tends to predict event B, but laws don't try to explain why this particular thing happens. Scientific laws and theories differ with respect to generality. Now, let's talk about the technical analysis rule. A technical analysis rule that is effective in all markets in all time scales would have higher scientific stature than one that works only on copper futures on hourly data. Laws also differ with respect to their predictive power. Those who those that depict those that depict the most consistent relationships are the most valuable. All other things are equal. So the most important type of scientific law is the functional relationship. It summarizes a set of observation, forms an equation. The equation basically describes how a dependent value would be dependent on the independent value, and so on. Now let's talk about what is the role of logic when it comes to science, right? So what is the role of logic in science? Scientific knowledge commands respect, in part because its conclusions are based on logic. By relying on logic, empirical evidence to justify conclusions, science avoids two common fallacies that contaminate informal reasoning: appeals to authority and appeals to tradition. An appeal to authority offers as proof of the statement of perpetually knowledgeable person. Appeal to tradition is basically long standing way of doing things, okay? How people have been doing things traditionally, that is what is the appeal to tradition. An appeal to authority is basically given by a knowledgeable person. To its detriment, much of popular TA is justified on grounds of tradition or an authority rather than formal logic and objective evidence. In many instances, current authorities merely quote prior authorities who in turn quote yet earlier experts, and so on and so forth. The first rule of logic, okay, let's talk about the rules of logic now. And the first rule of logic is basically consistency. Now, Aristotle, again, invention of formal logic, which evolved from geometry. The Egyptians had been making accurate measurements of lines, angles, and calculating areas. Greeks, who intended, okay, this is an axiom. Formal logic is a branch of mathematics which is concerned with the laws of correct reasoning that are used to formulate and evaluate validity of arguments. In contrast to informal inference, if the rules of formal logic are followed, the true conclusion is guaranteed. The most fundamental principle of formal logic is the rule of consistency. It is expressed in two laws: the law of excluded middle and the law of non contradiction. Okay, the law of the excluded middle requires that thing that must sorry, let's again read this. Law of excluded middle. The law of the excluded middle requires that the thing must either possess or lack a given attribute. So it should either have a given attribute or it should basically either not have a given attribute. There is no middle alternative. Okay, so middle, whatever is there in the middle, that is never ever considered. It either has it or it doesn't have it. So that is the law of excluded middle. Or said differently, the middle ground is excluded. A statement is either true or false. It cannot be both, or it cannot be half half, and so on. However, the law is only properly applied to situations that are binary and is easily misapplied to situations that are not truly two state. Now, closely related to the law Closely related to the law of the excluded middle is the law of non contradiction. Now, what is the law of non contradiction? It tells us that a thing cannot be both and not be something at the same time. A statement cannot be true and true at the same time, right? An argument that allows for its conclusion to be true and not true at the same time is said to be self contradictory. So these are the two laws. Okay, first thing is that middle there should be nothing in the middle, and the statement or law of non-contradiction means that it should either be true or it can be false. You cannot have both the things together. As will be shown in the subsequent sections, these laws of logic are great. They are really used in the um, even in the technical analysis. Now let's talk about the propositions and arguments. Logical inference takes two distinct forms, deduction and induction. We will consider each separately and then see how they will be used together in the logical framework of modern science. So now let's also see the hypothetical deductive method. However, before considering these forms of inference, some definitions are there. So now what is a proposition? A declarative statement that is either true or false, sometimes referred to as a claim. For example, the statement, the head and shoulder pattern has more predictive power than a random signal is a proposition. A proposition differs from other types of statements because it does not possess the attribute of truth of falsity such as exclamations, commands, questions. Okay, so a proposition can only be affirmed or it can be denied. So either it has to be proved true or it has to basically be proved false. And then we have an argument, a group of propositions. Now, arguments are a group of propositions, okay, one of which is referred to as conclusion, which is claimed to follow logically from other propositions called premises. Premises. Thus, an argument asserts and that premises provide the evidence. So basically, you know what an argument is. I'm not even getting into the detail of it. Deductive logic. As mentioned earlier, there are two forms of logic, right? So one is the deductive logic and one is the inductive logic. This section basically considers the deductive logic. So let's talk about the deductive logic. Categorical syllogisms. A deductive argument or a deductive logic is one whose premises are claimed to provide conclusive, irrefutable evidence for the truth of its conclusion. A common form of deductive argument is the categorical syllogism. It is comprised of two premises and a conclusion. It is so named because it deals with logical relations between categories. It begins with a premise that states a general truth about a category. For example, all humans are mortal, and it ends with a conclusion that states a truth about a specific instance. Socrates is mortal. So all humans are mortal. That's why the Socrates are also okay. Wait. So, what is the premise one? All of the humans are mortal. What is the premise two? Socrates is a human. So, since these two factors are true, what is the conclusion? Socrates is also mortal. Right. So, this is deductive logic, and the first one we saw was categorical syllogisms. Notice that the argument's first premise establishes a relationship between two categories, which is humans and mortals. All humans are mortal. The second premise makes a statement about a particular individual member in the first category. So Socrates are a part of humans, right? So that's why. Now, what is the general form of a categorical syllogism? So again, this is one of the deductive logic. Keep that in mind. Premise 1. All members of category A are members of category B. Premise 2. X is a member of the category A. So what does this infer? We can infer that X is a member of category B. Okay. So deductive logic has one especially attractive attribute, certainty. A conclusion arrived at by deduction is true with complete certainty. But this is so only if two conditions are met. The premises of the argument are true and the argument has valid form. If either condition is lacking, the conclusion is false with complete certainty. Therefore, a valid argument is defined as one whose conclusion must be true if the premises are true. Or said differently, it is impossible for a valid argument to have two premises and a false conclusion. In summary, conclusions arrived at by deduction are either true or false. If either valid form or true premises are lacking, then the conclusion is false. If both are present, the conclusion is true, but there is no sort of middle ground. It is important to also note that the truth and validity are two distinct properties. So, truth and its opposite is basically falsity, and they are properties that pertain to an individual proposition. A proposition is true if it conforms to fact, because premises and conclusions are both propositions. They are aptly characterized as either both are true or either both are false. The premises all pigs can fly is false. The premises Socrates is a man is true, as its conclusion Socrates is mortal. Validity is a property that pertains to form an argument. In other words, validity refers to the logical relationships between propositions comprising the argument. Validity or lack, therefore, describes the correctness of the logic inference linking the premises to the conclusion. But validity makes no reference to the factual truth of the argument's premises or conclusion. An argument is said to be valid if when its premises are true, but also again it's only an argument is said to be valid if the premises are true, its conclusion also must be true. An argument can be valid even if it is composed of false propositions, so as long as the logical connections between the propositions are sound. The categorical syllogism that follows has valid form because its conclusion is logically compelled by its premises. Yet its premises and conclusion are clearly untrue. See, all humans are immortal. Socrates is a human, therefore, Socrates are immortal. According to the premises which are given, the particular statement is true, but factually, this is not true, right? Because validity has nothing to do with the matter of fact. Validity can be demonstrated with arguments or diagrams called Euler circles, which make no factual references whatsoever. So, whatever is given in the particular diagram, that is what we will assume to be true, right? We are not going to sit and worry about whether it is factually right or not. So let's see figure 36.3 makes clear why argument 1 is valid but argument 2 is not. Argument 1 is valid because its conclusion x is b. So we have cars in the outer circle, inside it we have sports cars. So obviously if something is true for cars, then it will be true for sports cars as well. So however, argument 2 is not valid because of conclusion. Now let's actually look at the arguments. Argument 1. So this is category A is X, category B is the outer one, category A is inside now, category X. Okay. All A's are B's. X is an A, therefore X is a B. Argument 2. All A's are B's, X is B, therefore X is an A. No, X is a B. How can X is a B? All A's are B's, but we don't know if all B's are A's. So this is false. Very simple. So you can read the answer because there's no I'm not explaining it because this is very simple. Okay. Now we saw what are categorical syllogisms, right? Now let's see what are conditional syllogisms. Now, conditional syllogisms, the logic of scientific arguments, another form of deductive argument, and the one that is central to scientific reasoning is the conditional syllogism. It is the logical basis of establishing the discovery of new knowledge. Like the categorical syllogism, the conditional syllogism is also composed of three propositions, two premises, and a conclusion. It is so named because its first premise is a conditional proposition. A conditional proposition is a compound statement that combines two simple propositions using the word if then. The proposition following if is referred to as the antecedent clause, and the proposition following then is referred to the consequent clause. Okay, so if antecedent clause, then consequent clause. For example, if it is a dog, then it has four legs. So these are conditional syllogisms. In the example, it is a dog is the antecedent clause and it has four legs is the consequent clause. If a technical analysis rule has predictive power, then its backtested rate of return will exceed zero. Our ultimate goal is to be will be to establish the truth of antecedent clause, right? So if it is a dog, affirms the truth of the antecedent. It is not a dog, denies the truth. It has four legs, affirms the truth. It does not have, denies the truth. The conclusion of the conditional syllogism affirms or denies the truth of the remaining clause of the first premise. In other words, the conclusion references the clause that is not mentioned in the second premise. For example, if the second premise refers to the antecedent clause of the first premise, it's a dog, then the conclusion would be it has four legs. If it is a dog, then it has four legs. It is a dog affirms the truth. Therefore, it has four legs, affirms the truth of the consequent. When a conditional syllogism possesses valid form, its conclusion is logically compelled by two premises. Moreover, if it is valid in its valid form and premises are also factually true, then the conclusion of the conditional syllogisms must also obviously be true. Now, what are the valid forms of conditional syllogism? There are two valid forms of conditional syllogism: affirming the antecedent and denying the consequent. In an argument that affirms the antecedent, the second premise affirms the truth of the antecedent clause of the first premise. In an argument that denies the consequent, the second premise asserts that the consequent clause of the first premise is not true, affirming the antecedent. If it is a dog, then it has four legs. It is a dog. So obviously, then the conclusion would be that it has four legs. In the valid form, the second premise affirms the antecedent clause by stating it is a dog. These two premises deductively compel the conclusion that it has four legs. Now let's see this. If A is true, then B is true. A is true, so that's why B is true, right? Now let's see another example. Okay, if it is a dog, then it has four legs. It does not have four legs. Therefore, it is not a dog. Denial of the consequent follows a general form. If A is true, then B is true. If B is not true, then A is not true. So this is sometimes shortened to if A, then B, not B, therefore not A. Notice that this form of argument uses evidence, right? It uses the evidence and then it basically predicts. Now, that's something which we saw. Now, let's see what are the informal form of conditional syllogism. An important reason for using formal logic is the difficulty people often have when reasoning informally about conditional syllogisms. Psychological studies have shown that people tend to commit two fallacies when reasoning about conditional propositions: the fallacy of affirming the consequent and the fallacy of denying the antecedent. So, that shouldn't be something which will happen. We can only affirm the antecedent and we can deny the consequent, but we can never affirm the consequence and decide and deny the antecedent. If it is a dog, then it has four legs. It has four legs, therefore it is a dog.